or which of the following functions f is f of x equal to f of 1 minus x for all values of x. So for these function questions, especially on these official practice exams, I've noticed they tend to take a long time, especially if you wanted to do them algebraically. And so typically my strategy here is to plug in numbers, but you have to be very certain about what your criteria is going to be once you plug in those numbers. Because so if we're plugging in numbers, and this is a must be true question, because we want, when is this true for all values of x? So if we're plugging in numbers and we get two sides of our equation that are equal to each other, that does not mean we can select that answer choice, because we've only proven that it is true for that specific set of values. What it does mean is we can eliminate the answer choice if our two values, f of x and f of 1 minus x, do not equal each other. So really what I'm trying to do here is eliminate the 4 wrong answer choices. And if it ends up that I get 2 answer choices where the numbers I plugged in are equal to each other, then if I have the time, I can try with a new set of numbers, or I can just make a 50-50 guess and move on. But I have found that that is the best compromise with longer function questions. So let's see how we do this. So if we're testing numbers here, let's say x is equal to 3. So we want a case where f of 3 is equal to f of 1 minus 3, which is f of negative 2. And so start with A. What is f of 3? F of 3 should be 1 minus 3 is equal to negative 2. F of a negative 2 is equal to 1 minus negative 2, which is just 1 plus 2, which is equal to 3. Negative 2 is not equal to 3. So we can eliminate that answer choice. Statement, or not statement 2, answer choice B says f of 3 would be equal to 1 minus 3 squared, which is 1 minus 9, that's negative 8. F of a negative 2 would be 1 minus negative 2 squared. That would be 1 minus 4. These will not be equal to each other because negative 8 is not equal to negative 3. D can be eliminated. And so you can sort of see that if you choose unique numbers, you don't want to choose 0, you don't want to choose 1 or anything like that, because then you're increasing the chances of getting 2 choices that are equal to each other. But if you choose unique numbers, you usually can eliminate the 4 wrong answer choices. Now they're starting to get a little bit harder though. So C, f of 3 would be equal to 3 squared, which is a 9, minus 1 minus 3 squared. So minus negative 2 squared. So that's minus 4. That's equal to 5. And then f of negative 2 is equal to negative 2 squared, which is 4, minus 1 minus negative 2, which is the same as 1 plus 2. So that's 3. Squared, so that's 4 minus a 9, which is equal to negative 5. And so 5 is not equal to negative 5, although we are close here. D, f of 3 would be 3 squared, which is 9, times 1 minus 3 squared. So that's 4. 36. F of a negative 2 would be negative 2 squared, which is 4, times 1 minus negative 2, which is 1 plus 2, which is 3 squared, so 9. So here we got a match. So if you were short on time or a little bit cocky, you could select a D as your answer choice. But remember, we have not proven D is the answer yet. We have just shown that this example here works. And we can prove D is the answer if we can eliminate E. So let's try and do that. So f of 3, in this case, would be 3 over negative 2. F of a negative 2 would be negative 2 over 3. So reciprocals of each other. Negative 3 halves is not equal to negative 2 thirds. So we can eliminate E and D. ends up being our answer.